Welcome to Math 99 Week 1 examples. Hopefully these examples will help you out with your practice exercise problems. Okay, we're going to go through a few problems dealing with fractions and decimals and a few operations. Alright, so we're going to start with this one. Represent the numbers 20 over 5 and 2 over 3 on a number line. To do this, let's create a number line first of all. And two number lines could be used for this, or just one. So let's start with 0. Now, let's look at the 2 over 3 first. 2 over 3 means that that is in between 0 and 1. What you would want to do is make 3 equal divisions in between 0 and 1 to represent the thirds, 2/3. So to represent the thirds, that's about equal. I have 1, 2, and then 3. 3 equal portions between 0 and 1. That represents the thirds. 2/3 would be 1, 2. That second place right there would represent 2/3. So again, the thirds, the bottom number tells you how many numbers, how many equal spaces should be in between 0 and 1. And then the top number tells you where to put your point. Okay, 20 over 5. Now you would want to simplify 20 over 5 first. And remember, a fraction bar is the same thing as division. So if you can divide evenly and divide it out into a regular number, then go ahead and do that. So 20 divided by 5 is 4. So to represent 20 over 5, sorry about that, 2, 3, 4. So the point 4 would represent 20 over 5 because 20 over 5 is equal to 4. And that's how you would plot those numbers on a number line. Okay. Change the fraction to a mixed number. Alright, to change that fraction to a mixed number, you would want to divide the bottom number, denominator, into your numerator. Okay, so 7 will go into 60. That's right, about 8 times. 8 times 7, 56. Subtract that out. You have 4 left over. Now this represents your whole number. That represents your top number. The remainder represents your top number of your fractions. And your denominator always stays the same as your original denominator. So 8 4/7 would be that. So we just divide, and whatever we get up here represents the whole number. Whatever our remainder is represents our new numerator, top number. Denominator always stays the same. Okay, change the mixed number to an improper fraction. So now we're going to go in reverse order. So 4 3/5. If I want to change that to an improper fraction, we're going to multiply and then add. To get that, to get our new top number, again our denominator will always stay the same. So we're just doing just the opposite of what we did on the last screen. This time we'll multiply 5 times 4, which is 20, and then 20 plus 3 equals 23. And that's what you do every time. Multiply your denominator by your whole number and then add your numerator, and that gives you your new top number, 23/5. Okay, what is the place value of the 3 in the number 723,125? Well, your place value system, you have the ones, tens, hundreds, thousands, 10,000s, and then 100,000s there. So the 3 here is actually in the thousands place. The 3 is in the thousands place. Now if you had a decimal number, so in this case the 3 would be in the thousands place, that would be the place value. But if we had a decimal number, so for an example, let's say we had 7.251. Now the decimal, the numbers to the right of the decimal, you start counting a little bit differently. You start counting it with your tenths, and then your hundreds, and then your thousandths, and so on. So you don't start with the ones place on the right of the decimal, you start with your tenths, hundreds, thousandths, and so on. Okay? Alright, reduce the fraction to lowest terms. When you reduce a fraction to lowest terms, you're trying to find a number that can be divided into your numerator and your denominator. So a common factor. So a common factor of 3 and 21, or something that will go into both 3 and 21, is 3. So if I divide the top and bottom by 3, then I get 1/7. And that's been reduced to lowest terms because there's nothing else that'll go into both 1 and 7 besides 1. So you just keep dividing by common factors, and you have to divide the top and the bottom by the same number to keep the fraction equivalent until nothing else will go into each one of your numbers. So 3 divided by 3 is 1. 21 divided by 3 is 7. What is the relationship between 3/7 and 2/13? Is it greater than, equal, or less than? Now, one way to compare fractions is by getting a common denominator. And one way to get a common denominator, if it's not obvious, and common denominators are multiples, common multiples of numbers. One way to get a common denominator, if the common multiple is not obvious, is to multiply each denominator by the opposite denominators. So in other words, I could multiply this 7 times 13, but again, remember, whatever you do on the bottom or top of your fraction, you must do on the bottom. So if I multiply the bottom by 13, I have to multiply the top by 13 to keep it equivalent. 7 times 13 is 91. 3 times 13 is 39. And then I can multiply the 13 by the other denominator up here, which is 7. Two times 7 is 14. 13 times 7 is 91. Now that our denominator are in equal parts, all I have to do is compare the numerators to determine which one of those fractions was larger, or what was the relationship. So in this case, the relationship is 3/7 is greater than 2/13. Because when I got a common denominator, I had 39 over 91 compared to 14 over 91. So 3/7 would be greater than 2/13. Okay, convert meters to feet. The first thing we would need to know is how many feet are in a meter. Well, I know that 1 meter is equal to about 3.28 feet. So therefore, if I want to find out how many feet are in 7 meters, I would simply just multiply 7 times 3.28, and that will give me about 22.96 feet. So that tells me that 7 meters is equal to about 22.96 feet. Which of the following are like fractions? Well, if you read your text, we find out that like fractions have the same denominators. So looking at these two, or looking at these three fractions, 3/7 and 5/7 have the same denominators. Therefore, 3/7 and 5/7 are like fractions. Like fractions have the same denominators. Which of the decimals are like decimals? Again, if you read your text, like decimals have the same number of numbers after the decimal. So here I have 1, 2, 3, 4 numbers after the decimal. In this second one I have 1, 2, 3, 4 numbers after the decimal. In the third one I have 2 numbers after the decimal. So therefore, this first and second number, the first and second numbers are like decimals. Okay, so those will be the like decimals. Again, like decimals have the same amount of numbers after the decimal. Like fractions have the same denominator. Add these two fractions after converting them to their LCD. So in order to add fractions, we have to have equal parts in our denominators. Otherwise, we can't add the numerators. So again, we have to find the common multiples of the numbers. So let's look at multiples of 12 and 15. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36, and so on. 48, 60, 72. Maybe that's enough. Let's look at multiples of our other denominator, 15. 15, 30, 45, 60. Well, I've just found the common multiple, the first common multiple, or the least common multiple, which is 60. So 60 would be my LCD. Now, I'm starting off with 7 over 12 and 4 15ths. Before I can add those, I have to get the common denominator, the least common denominator, which we determined was 60. But again, if I change my denominators, I have to change my numerators. So I have to figure out, what did I multiply 12 by to come up with my new denominator of 60? Well, I multiplied it by 5. So in order to keep this fraction equivalent, I have to also multiply my top number by 5. Same thing over here. What did I multiply 15 by to come up with 60? Well, I multiplied it by 4. So again, to keep the fraction equivalent, I must multiply the top number by 4, which gives me 16. Now I keep that denominator once I get that common denominator, and I simply add the two top numbers, the numerators. 35 plus 16 gives us 51 over 60. And again, we could check to see if that is in simplest form. Okay, so let's check that. Is there a number that'll go into both 51 and 60? I think 3 will go into both of those. So let's try dividing by 3. Okay, 3 will go into 51 17 times, and 3 will go into 60, or 60 divided by 3 is 20. So my final answer, making sure my answer was simplified, would be 17 over 20. Okay, I hope those problems will help you out, will benefit you in those practice exercises for week 1. I wish you well, and be sure to review these and go through the online lectures, the textbook, and those helpful videos at www.khanacademy.org, and you can find that in the announcement area. All right, everybody have a good week.